Hey everyone, so today we're going to be covering Chapter 16, Section 2, the electric force. Let's start off with talking about the Coulombs Law. So Coulombs Law basically is F is equal to K absolute value Q1, Q2 over R squared. So what exactly do these variables represent? Now F obviously represents the electric force. Q1 and Q2 represent the electric charges, and R represents the distance between the centers of the charges. Now, K, we're going to talk about K later, but K is basically the Coulombs law constant, okay? Now, let us talk more about K. K is basically, as we said, the Coulomb's law constant. Its value depends on the medium that surrounds the charges, okay? And the medium that we usually use is air, in which the value of K is 9 times 10 to the power of 9. So the value of K in air is 9 times 10 to the power of 9. So this is the value that we usually use when we are calculating the electric force, okay? So now it is important to note that the product of the two charges, so the product of Q1 and Q2 can be positive or negative. Okay? Which is why, as you can see here, we use absolute value. Okay? We use absolute value because force can't, the magnitude of force can't be negative. The negative sign just simply shows what direction the force is going towards. So if it's going towards the left, it would be negative. However, if it's going to the right, it would be positive. So this the value, as we said, of the product of the two charges can be positive and negative, which results in the resulting sign of F being positive or negative. Okay, which we eliminate in order to not get confused by the force, actually, like the magnitude of the force being negative, because it could not, magnitude can never be negative. So now let us do one example about the concept that we just talked about. Okay, so here they tell you a balloon rubbed against denim gains a charge of negative 8.0 microcoulombs. What is the electric force between the balloon and the denim when the two are separated by a distance of 5.0 centimeters? Assume that the charges are located at a point. Okay. So here we have to use Coulomb's law, of course, which is K Q1 Q2 over R squared. Here Q1 is equal to negative 8.0 times 10 to the power of negative 6, because remember, okay, this you should take a note of this. 1 microcoulomb is equal to 1 or 10 to the power of -6 coulombs. Okay, 1 nanocoulomb is 10 to the power of -9 coulombs. So this is a conversion of units that you have to know, since they are very oftenly used when solving these types of questions. Okay, now that we know that, we now understand why we wrote a -8 times 10 to the power of -6 coulombs. Q2 now, they don't really say what does the charge of Q2. However, you should know what it is depending on the charge of Q1. Like we said before, the electric charges are, or the charges are conserved, so you cannot destroy them or create them. Okay, so here, since Q1 the charge is -8.0 times 10 to the power of -6, since the charge of the balloon is that means that the denim lost, okay, the denim lost this amount of electrons, okay, so that means this amount of protons, or the denim has this amount of protons more than electrons. Okay, so here the charge would be 8 times 10 to the power of -6 coulombs. So now we substitute these values. We know that k is equal to 9 times 10 to the power of 9, and r, if you want to keep it in centimeters, it is 5. However, I prefer to convert it into meters. So you divide 5 by 100, and you will get 0.05 meters. Okay, so now you basically just substitute these values, right? 8 times 10 to the power of -6 and -8 times 10 to the power of -6 over 0.05 squared. Okay, and now if you use your calculator, you will get F is equal to 230.4 newtons. And this will be your answer. Now let us talk about the superposition principle. Okay, this principle basically says that we have many charges present in a region. Okay, now the resultant force, that's represented by Fr, the resultant force on any single charge equals the vector sum of all charges acting on that charge, or in the charges field. Okay, so basically we know that charges, the force does not only go electric forces do not just it's not just between two charges. We know that force is made from the contact between, or the interaction between two charges, but we never have just two charges in a place. There are multiple different charges, And in order to find the resultant force, okay, you have to add the vector sum. You have to add the vectors of all the charges acting on that charge. So let's say you want to find the electric force acting on point A, okay? And here you have Q1 and here you have Q2. So you have to find F1A and F2A, meaning the force acting by Q1 on point A and force acting by Q2 on point A. And when you find these forces, you basically just then go on by finding the components and all that, and we'll talk about that later when we solve an example using this principle. Thank you everyone for watching this video. If you have any questions, don't be afraid to leave them in the comment section down below, or email me at educology.help@gmail.com. I've left some notes for this lesson in the description box down below. Thank you and have a good day.